Today we're going to learn a new method to solve a quadratic. And why do we have to learn a new method to solve a quadratic? Doesn't factoring help us out all the time? Well, not necessarily. Because sometimes we can have answers, however you can't get those answers by factoring. And the reason is that the values that are answers, those x-intercepts, are not rational numbers. And the only answers you get from factoring are answers that are rational, ones that you can write as fractions. So there's other types of numbers as well in the real number system, and those are called irrational numbers. And so we're going to see some of those. We saw some actually when we dealt with square roots, when we solved using square roots. And that concept is going to be taken a little bit further in solving by what we call completing the square. So the first few problems on tonight's homework are going to ask us to complete the square, to form a perfect square trinomial. So let's go over real quick what a perfect square trinomial looks like. Basically what it's going to be is two binomials that are exactly the same. So let's take a look at this one here. Let's say it was x plus 3 quantity squared. And before we get to what number needs to go in the last digit spot, let's go ahead and take this expression here, x plus 3 quantity squared, and write it out twice. And what I'm going to do is I'm going to multiply these two binomials. Now basically when you multiply binomials, we distribute. Use that distributive property twice. Multiply the first value in this binomial by each of the values in the second one. Then do the same thing with the second value. Multiply it by each of the terms. So what I call this is the FOIL method. I multiply the first terms here. X times x makes the x squared. And we then multiply the x times this 3, and that makes a 3x. Then we move over to this 3 and multiply it. And so we have the 3 times the x makes another 3x. And this 3 times this 3 makes a 9. So what you'll notice about a binomial that's being squared, it makes a square trinomial. And so what a square trinomial has is, first of all, this first value is a perfect square, and the last value is a perfect square. Well, these two terms, since the values inside the two binomials are the same, will always be the same value. The outer and inner terms will always add to make will add together, and they will always be the same number. In this case, 3x and 3x will add to make 6x. So what we're going to end up doing is using this concept here to help us figure out what this last term is going to be. Because if you took these two terms, the 6, and we divided it by 2. So you took this, just the 6 right here. You took 6 and we cut it in half. So we divided it by 2. We'd end up with 3. And 3 is the number that we have right here. Well, all you're going to do is take that 3, since it's going to be the last term, you're going to square that. And that will give us our 9, the value that we get for the last term. And that's what we're trying to do on these problems. And we'll use this concept when we're solving these problems down below. So basically you're taking this 4, and you know that the outside terms and the inside terms are going to add together to make 4. And so what we're going to do is we're going to take this 4 and we're going to cut it in half. So I'm going to multiply it by 1/2. And that makes 2. So basically what I know is that the last terms in the two binomials, I know x and x make x squared, I know that the last terms are going to be 2 and 2. Well, since you multiply those last terms, I'm going to square that number. I'm going to square the 2, and that gives me 4. And that's the number that makes this a trinomial square. And so this is the way it would end up factoring, is x plus 2 and x plus 2. Same thing over here. You're going to take this negative 16 and you're going to cut it in half. And when we cut that in half, we end up with a negative 8. And so right away, I know what the last terms are going to be. I know it's going to be x minus 8 and an x minus 8. And so that tells me right away that I know I just need to square that number because the last terms get multiplied. And those last terms are exactly the same. So if you square that negative 8, that'll give us our number that we have as the last term of those two binomials, which is 64. Now this one here, a little bit different because you don't see too many problems. We haven't seen any trinomial squares that have a fraction as the last term. We've always seen just regular whole numbers as that last term. But here we're going to see a fraction because this is an odd number. Because again, we have to cut 7 in half, and that makes a fraction. Just leave it as this fraction. So basically what this would look like, if I went ahead and wrote it out, it would be x plus 7/2 and x plus 7/2. So when you go ahead and multiply those last terms, you're basically squaring that number. You're taking 7/2 and squaring it, and that gives us 49/4. 4/4, and that's the number that goes as the last term in that trinomial. So we're going to be using this concept to do a process called completing the square, which solves the quadratic, the same type of answers we'd get when we factored. And so let's take a look at this first problem. We're going to use that concept of completing the square. And again, this one's set up for completing the square because we basically want to make this right here a perfect squared trinomial. But we only have two terms, so we need to add an expression, add another number right here to make this a perfect square. So you're basically going to take this middle term here, the 6, and you're going to cut it in half. And that gives us 3, and then you're going to take that 3 and square it. And that makes 9. So that's the number that you have to add to both sides. See, if I add it to both sides of the equation, it keeps the equation in balance. And so here's what we have now. We've got an x. Now you can go ahead and rewrite this in the factored form. X plus 3 quantity squared. So we basically took this trinomial and wrote it out as two binomials. But see, since they're the same binomial, I just wrote it as a quantity being squared. This equals, now I add these numbers right here. When I add those two numbers, I end up getting a positive 1. And so from this point, now we're going to think of this as like the problem with the square roots. We got rid of a squared symbol by taking a square root. And so if I take the square root of both sides, it cancels out this squared symbol. But remember what happens when we take the square root. Remember, there's a principal square root and a negative square root, and that's what we have here. So we've got to make sure we write both of them down. So the square root of 1, we're going to have two possible answers that we could have gotten. We could have had either a positive 1 or a negative 1 that this would end up equaling. So now we want to find the values of x that make that the case. So you're going to end up subtracting 3 from both sides, and then you've got two problems to set up. See, here we have a positive 1 minus 3, which makes the negative 2. And then we also have a negative 1 and take away 3, which ends up making negative 4. And those are the two answers that we end up getting. So negative 2 and negative 4. Now we could have solved this by factoring a lot faster, but some problems you won't be able to solve by factoring, and that's why we need to have another method like completing the square. So let's take a look at another one here. We have it in that form in which we can solve this by completing the square. So all we have to do is take this 4, and we take half of it. And then from there, we get 2. Now we take that 2 and you square that number, and that gives us 4. So 4 is the number that you're going to end up having to add to both sides to make this a perfect square trinomial. So when you go ahead and factor this trinomial that I'll underline right here, when you factor this is going to end up factoring as an x plus 2 quantity squared. So the two numbers that multiply to make 4 are 2 times 2. Then they add to make this 4x. So on this other side, it equals 16. That's what I get when I add the 12 and the 4 together. So that's how I got that 16. And then I go ahead and take the square root of both sides. And what that will do, the reason why I do this trick is because I want to cancel out that squared symbol. And so that will leave me with a linear equation that I can solve. See, now I just have x plus 2, and it equals plus or minus 4, because there's two numbers that can make 16, either a positive 4 and a positive 4, or a negative 4 and negative 4. And so what we need to do is figure out those values of x that make that the case. And so the way we do that is just do an opposite operation, and we get the x by itself. And so in this case, we'll set up our two problems. We've got the positive 4 take away 2, which makes 2. We've got the negative 4 take away 2, that makes negative 6. So there it is. Negative 6 and 2 are the two x-intercepts. Again, you could have solved by factoring a whole lot faster. However, again, as I said before, sometimes you won't be able to factor. So here we take this negative 2 and we take half of it. Now when you take half of a negative, you end up with just still a negative. But you're going to take that negative 1 and square it. It's going to make a positive 1. And that's what you're going to end up adding to both sides. So I go ahead and do that, and here's what I get when I factor this trinomial right here. So I factor that trinomial, and I get two binomials exactly the same. They're going to be an x minus 1 this time, quantity squared, because they had to add to make a negative 2. So on the other side, I still have it equaling 16, and I'm going to go ahead and cancel out that squared symbol. The way we're going to do that is take the square root of both sides. So when we do that, we end up with just an x minus 1. This all equals plus or minus 4. Again, there's two numbers that make 16, either 4 times 4 or negative 4 times negative 4. So from that point, all you have to do is add this 1 to both sides, and we'll come up with our value of x. And so we can go ahead and set up our two problems. We'd have a positive 4 plus 1, which makes 5. And we'd have a negative 4 plus 1 that makes the negative 3. So there it is, negative 3 and 5, the two x-intercepts. Now, taking a look at the next one, we can go ahead and take this 13 and move it to the other side first. You always need to isolate if you're using this method of completing the square. We're going to move the 13 over to the other side, and we have this now as x squared minus 8x equals negative 13. So again, you have to isolate that constant on one side, because what you're trying to do is make this a perfect square trinomial. We just need to figure out what number it is we have to add to both sides. So the way we're going to do that is take half of the b term here, take half of 8, or negative 8, makes negative 4, but then you're going to take that negative 4 and you're going to square that number. And that's the number that you have to add to both sides. So I'm going to add a 16 here, I'm going to add a 16 here. And so from this point, now what we can do is we can go ahead and factor this, and this will factor down to an x minus 4. See, negative 4 and negative 4 multiply to make 16, but they add to make negative 8. And this is a quantity being squared, and all equals 3. So this is an instance where we would not be able to factor this problem, yet it still has solutions, and the solutions are irrational. And so what we're going to end up doing is take the square root of both sides, and we're going to rewrite this as an x minus 4 equals plus or minus the square root of 3. Now we're going to leave this in the exact form for right now. If we wanted to, we could simplify this, or an approximation of this would be about 1.7. And then we could go ahead and do that opposite operation and come up with approximate answers. But for our case right now, we're just going to leave it in the exact form. So I'm going to add that 4 to both sides, and the way we're going to write our answer is just 4 plus or minus the square root of 3. And again, if we wanted to come up with actual answers, or approximations, this is the actual answer, we could go ahead and approximate that square root to do that. Well, let's take a look at the next one. We've got another one similar to that, where we have to move this 34 back to the other side. So I'm subtracting that 34, and I can go ahead and rewrite my equation. It's an x squared plus 6x equals negative 34. Notice I left some space here because I am going to complete the square. I'm going to find out what number it is I have to add to this expression to make this a perfect square. The way I do that is I take half of 6, which is 3, and then I square that number and I get 9. So 9 is the number that you have to add to both sides to make this a perfect square trinomial. And so when we go ahead and factor this trinomial here, we end up with an x plus 3. So we've seen this before. 3 times 3 makes the 9, and they add to make 6. Well, we go ahead and do this subtraction right here, and take 9 from 34. We end up with a negative 25. Well, we're going to have a problem with this problem, and the reason is because it equals a negative. See, if you take the square root of both sides, we could take the square root of this first term here, but we can't take the square root of this one and get real roots. So this does have answers, but we learn about those in the next algebra class. But for this class, what we say is that this does not have solutions. There are no solutions, 0 the slash through it, or we could say no x-intercepts. Basically, this graph does not cross the x-axis. So that would be our answer right there, no x-intercepts, no solution. And the reason was because of that negative sign that we were trying to take the square root of. We can't find two numbers that multiply to make a negative 25 that are exactly the same. Well, the last problem here, we're going to go ahead and move that 35 over, so we have an x squared minus 2x equals 35. And you go ahead and isolate this negative 2 and take half of this value, and this ends up equaling a negative 1. You square that number, you get 1. So we're adding 1 to all sides. And so when we factor this, it ends up factoring as an x minus 1 quantity squared equals 36. You take that square root of both sides, and you end up with a x minus 1 equals plus or minus 6. You add 1 to all sides, and you get your answer. And so we get two answers, 7 and -5, and those are our solutions. Well, these are similar problems to what you'll see on tonight's homework. Good luck.